Okay. Now we are going to discuss what is how we can manage the transactions. Transaction management using Spring UOP. Okay. Just before discussing transaction management, first we need to discuss the ACID properties of database. Okay. What are the ACID properties of database? What are the ACID properties of the database? All of you know the ACID properties of database? Please raise your hands. Those who doesn't know what are the ACID properties? Only one? What's enough? You had an Oracle course now? Don't you remember? Don't you remember? Just ACID properties has abbreviation: atomicity, consistency, isolation, durability. These are the four ACID properties of database which should be maintained for any transaction. Which should be maintained for any transaction. Is the responsibility of the developer to maintain the ACID properties for all the transactions. It's the responsibility of the developer to maintain the ACID properties for all the transactions, for all the database transactions. Okay. A database transaction may contain n number of SQL statements. A transaction means it may contain one SQL statement or multiple SQL statements. Okay, let's consider like we have 5 SQL statements. Okay, 5 SQL statements are committed together. Then that is called as a transaction. A transaction is nothing but the SQL statements that are executed between two successful commits. Between two successful commits, if you execute any SQL statements, then it is a transaction. Between two successful commits. if we execute any SQL statements, then that SQL statements come under a transaction. Between two successful commits, if any SQL statements are executed, then those SQL statements come under a transaction. See, we may execute 4 SQL statements or 5 SQL statements. Until we execute commit, they will not be permanently committed to the database. Okay? Even if we execute multiple SQL statements, we may execute like this. Sorry. We are inserting one row. We have updated one row. Did we commit? No. Until we commit, it will come another. Sorry. Until we commit, it will come another same. Until we commit, the changes are not permanently hit the database. So, how many statements are there in the transaction? There are 2 statements in the transaction. Between 2 successful commits or 2 successful rollbacks. In general, we don't consider rollbacks. Between 2 successful commits, okay, if we execute any statements, then those statements will come under a transaction. Okay, then understood what is the transaction? If we have understood what is the transaction, then we'll discuss what are the ACID properties of a transaction, why these ACID properties should be maintained. Okay, the ACID properties of a transaction. The first one is atomicity. The first one is atomicity. Atomicity tells one or none. Simply one or none. That means if there are multiple SQL statements in a transaction, okay, just it's not one or none, all or none. Okay, there are multiple SQL statements in a transaction. Either all the statements should be committed, either all the statements should be committed, or none of the statements should be committed. Okay, either all of the statements should be committed or none of the statements should be committed. Let's consider like if there are 5 SQL queries that are performed in a transaction, then let's consider like there is a problem with the 4th query. Okay, the first 3 queries should not be committed, they should be rolled back or reverted back. Okay, so in a transaction Either all the SQL statements should be committed or none of the SQL statements should be committed. All or none. That is atomicity. Okay? The acid property that represent all or none. Either all the SQL statements should be committed or none of the SQL statements should be committed. If there is a problem in at least one SQL statement, then the remaining SQL statements should not be committed. Okay? This kind of property is called as atomicity. Okay? Let's consider we are performing a bank transaction. Okay? Just I am transferring 1000 rupees to Srinath. Okay? What happens? Let's consider there is a problem while performing the transaction. See, I have 1000 rupees. I have 10,000 rupees. Among those 1000 rupees, I am transferring 1000 rupees to Srinath. Okay? I have 10,000 and I am transferring 1000 rupees to Srinath. Let's consider this is another transaction. Okay? Now, deduction of amount from my account as well as populating the amount to his account should be done under a transaction. Okay? Otherwise, it will be very difficult to maintain. Okay? Deduction of amount from my account. Okay? And addition or addition of amount into his account should be maintained under a transaction. Okay? Let's consider the amount was successfully deducted from my account. Okay? But because of some technical reasons, amount was not populated into Srinath's account. Now, is it the correct one? So, both the SQL statements should be atomic here. Both the SQL statements should be atomic. Deduction of amount from my account as well as population of amount into his account. Both the SQL statements should be atomic. So, either all should be committed, none of them should be committed. Understood? If they deduct amount from me and if they are not populating the amount into his account, is it a correct application? Whatever the reason it might be, whatever the technical reason it might be, the transactions should be atomic. That means either all the statements should be committed or because of any reason, if at least one of the statement is not committed properly, then the remaining statements also should be reverted. That is atomicity. The best example is the example that I have discussed. Okay? Now, the next one is consistency. Next one is consistency. Okay? The data should be consistent throughout the transaction. The data should be consistent throughout the transaction. Let's consider when I initiate the transaction, the available balance in Srinath, my account is 10,000. Let's consider when I initiate the transaction, the available amount in my account is 10,000. But when I am going to commit the transaction, it is 0. If that is the case, is it a perfect transaction? See, I have 10,000 in my account, then I am trying to transfer some money to Srinath, some 1,000 rupees to Srinath. So, while checking, it will check, okay, whether Srinath this account has 1,000 rupees to transfer or not. Yes, I have 10,000 rupees. Okay, so it will initiate the transfer. But the transfer will be committed only at the end, right? Only if Srinath can get 1,000 rupees successfully. Then only the transaction will be committed. But at the beginning of the transaction, I have 10,000 rupees. But at the end of the transaction, if I have 0 rupees, is it a correct transaction? No. So the data should be consistent in all the phases of the transaction. That is consistency. The data should be consistent in all the phases of the transaction. Okay. Now, next one is isolation. Isolation is the level of separation of one transaction from another transaction. Isolation is the level of separation of one transaction from other transaction. Let's consider like, okay, I am transferring 1000 rupees from my account to Srinath's account. Okay. At the same time, Sharad is transferring 1 lakh rupees from his account to Prasad's account. If 1 lakh rupees is transferred to Srinath's account, is it correct? No. These are two different transactions. I am transferring Srinath 1000 rupees, Sharad is transferring some 1 lakh rupees to Prasad. But if one transaction interferes with another, okay, what happens? 1 lakh will go to Srinath and 1000 rupees will go to Prasad. Then what happens? Prasad will beat like anything. No? So that happens. That may happen in real time. If multiple transactions are happening at the same time. So we need to maintain the transaction so that those transactions will be isolated. Those transactions should not interfere with one another. Okay, that level of isolation. There are different levels of isolation that we can maintain. That we will discuss. But we should isolate multiple transactions. One transaction should not interfere with another transaction. Okay, that is isolation. Durability. Let's consider like I have committed the transaction. Okay, I have the amount is deducted from my account as well as the amount is added to his account, but it was not committed now. At this point of time, if power fails, if there is a power failure or if there is a network failure, what happens? What should happen? Means at any cost, the transaction which is successfully completed should be committed. That is durability. Okay? At any cost, the transaction which is successfully completed should be committed. Okay? Whatever the issue it might be network failure or power failure or whatever the case might be, the transaction which is successfully completed should be committed. That is durability. Okay? For any reason, at any cost, the transaction which is successfully completed should be committed. And that is durability. Okay, understood? Now, just if there is any violation of the acid properties, okay, if there is any violation to the acid properties, okay, then what happens is just the transaction will become inconsistent, okay, and irrelevant. The transaction, if there is any violation in the acid properties, the transactions will become irrelevant. So we should manage the transaction, okay. If we don't maintain the transactions, okay, what happens? Okay, what happens if we don't maintain the transaction? Okay, if you don't maintain the transaction, there is a chance of dirty reads there is a chance of having dirty reads, non-repeatable reads, and phantom reads. You don't maintain transaction, there is a problem like this. Okay. What dirty read means? Let's consider like there is a transaction 1. Okay, which is having there is a statement 1 or transaction 1 which is having this is the first one, okay, and this is the second transaction. Second transaction is and again, if we are executing in the first transaction, this is the second transaction. This is the first transaction, and this is a second transaction. In the first transaction itself, again we are executing. Let's consider like first this happens, and then this happens, and then this happens. These two are in the first transaction. The first transaction itself, first I am executing select something, and after some time, after some statements or after some time, within the same transaction, I am executing the same statement again. But in between, if this transaction happens, okay, now will these two SQL statements return the same result? Will these two SQL statements return the same result? No. Just because in between this transaction is not committed, but this transaction happened. Okay, because since this transaction has happened, okay, these two SQL statements, even though they are in the same transaction, okay, they will not give consistent results. They will give different results. Okay, getting the different results for the same statement, getting the different result for the same SQL statement because of uncommitted transaction is called as a dirty read. Getting different results within the same within the same transaction because of an uncommitted transaction is called as dirty read. Okay. And if that happens with a committed transaction, then it is called as a non-repeatable read. The same thing happens with a committed transaction, then it is a non-repeatable read. Okay, then what is phantom reads means? Let's consider like let's consider like the ID 15 doesn't exist. The ID 15 doesn't exist, only 12, 13 and 14 exist. Then what is the size of the result? Let's consider like the ID 15 doesn't exist in HC_person. Then what is the size of the result? 2. The ID 15 doesn't exist, but 12, 13 and 14 exist. What is the size of the result set? The ID 15 doesn't exist in HC_person. Only 12, 13 and 14 exist. Then what is the size of the result set? 3. Obviously it will be 3. Just because if 15 doesn't exist, then the result set will contain the name of 12, 13 and 14. Now, this is the first transaction. And the second transaction, what it will do means, now what happens? Let's consider like in between these two statements of the first transaction, in between these two statements of the first transaction, if the second transaction happens, then will it give the consistent results for the size of the result set? Will it be consistent for the first and second transaction? Will be the size of the result set consistent for the first and second transaction? No, just because a row has been inserted in between in the second transaction. So this is a phantom read. If the size of the result set changes between two statements of a transaction, the size of the result set changes between two statements of a transaction, then it is called as a phantom read. Understood? To avoid this dirty reads or phantom reads or non-repeatable reads, we set some isolation mechanisms. Okay? Isolation mechanism or isolation properties. In dirty reads, without committing, if both the results, both the queries, if two different queries return two different results, even if not committed, then it is a dirty read. May happen. It may happen. If it happens, then it is a dirty read. See, to avoid these problems, we will set the isolation properties. Okay? What are the isolation properties that we can set? Means read uncommitted, okay? These are the isolation levels that we can set. This isolation level will provide some locking mechanism. Isolation levels will provide some locking mechanism for database tables. Isolation levels will provide some locking mechanism. See, same like in synchronization, we provide some object lock and class lock, right? In the same way, for databases also, the logging concept will be there. Okay, like until one user commits a transaction, the second user cannot use the table. Likewise, that range of locking mechanisms are there. Okay, in database level also. Okay, the isolation levels will set specific range of logs. Okay. Will set specific range of logs, okay, on the database table. Okay, the isolation levels will set the specific range of logs at the database table. Read uncommitted means, okay, it cannot avoid that there is phantom reads and non-repeatable reads. Okay, read committed can avoid dirty reads, but not non-repeatable and phantom. Repeatable reads can avoid dirty reads as well as non-repeatable reads, but not phantom reads. But synchronized can avoid all the reads. But if it is synchronized means, at a time only one query should be executed on a table. Will it give you the performance? See, whenever we increase the security, performance will be decreased. As per requirement and as per the load on the table, we should maintain the performance. We should not consider the maximum security that is available. If we go for maximum security level that is available, the performance will be minimum. Wherever the security go up, the performance will come down. It's inverse proportional. So, we should consider the range of the application and should maintain the security. Okay, we should consider the range of the transaction. Let's consider like at certain point of time, let's consider like the transaction will be in peak. Other time we can set the database property. Let's consider like the transactions are very low, we can set the database property. Like that. Okay? Like that, we should maintain the optimal security levels as per the requirement. It should not be maximum, it should not be minimum. Okay? These are the multiple isolation levels. Read uncommitted means it will not maintain any, it will not avoid any reads. Read committed means it can avoid dirty reads. Okay, repeatable read means it can avoid non-repeatable reads. Okay, synchronous means it can avoid any reads. Okay. Oh, now how we can maintain this transactions through Spring? Okay. See, these are the database level stuff. But since we are accessing the application through Spring, we can maintain the transactions through Spring itself by making use of Spring AOP. By making use of Spring AOP, we can maintain the transactions. Let us see how we can maintain the transactions using Spring AOP. Okay. And in order to maintain the transactions using Spring AOP, okay, we have some isolation properties, okay, and propagation levels. We can set some isolation levels and propagation levels. Just the propagation tells that, okay, when a transaction should be created, how a transaction should be executed. Okay, let's consider like there are some propagation properties or propagation strategies like okay, execute the transaction. Don't create a new transaction. Only make use of executing the existing transaction. There are some propagation levels like okay, even if existing transaction exists, okay, create a new transaction. There are some propagation levels like if there is an existing transaction, then make use of existing transaction. Otherwise, create a new transaction. There are some propagation levels like if there is existing transaction, then make use of existing transaction. Otherwise, execute without transaction. There are some propagation levels like if there is existing transaction, make use of existing transaction. Otherwise, throw exception. That depends upon the requirement of the user. The user wants to execute non-transactionally, we will execute non-transaction. The user wants, okay, to make use of only the existing transaction, not create a new one, then we will use the specific propagation level. The user wants to create a new transaction if it doesn't exist, then we go for some specific transaction. Okay, everything depends upon the requirement. Okay, that will be considered. That will be told by this propagation strategy. Okay, there are multiple propagation strategies that will discuss what one will do. But the propagation tells, okay, how and when the transaction should be created. Okay, when the transaction should be created and how the transaction should be used. The propagation tells when the transaction should be created and how the transaction should be used. And isolation will define the isolation property of the database. We have discussed, right? There are 4 isolation levels for the database. It will define the isolation level. Either it should be read uncommitted or read committed, okay, or repeatable, or it might be synchronized. Okay, you see here we have read uncommitted, read committed, repeatable, read and serializable. The default means, okay, just it depends upon the database. Okay, for SQL Server, default might be different. For Oracle, the default might be different. The default depends upon the database. Okay, each and every database will have a default isolation mechanism. A default will depend upon the database. Okay, the default isolation depends upon the database. SQL Server may have something as default, but Oracle may have some other thing as default. But isolation by default means it depends upon the database. The database default isolation mechanism. Okay. Then we have read committed, read uncommitted, repeatable read and serialized. Okay. Each isolation will define the level of isolation of one transaction from other transaction. Okay. We have 4 different isolation levels. Okay, that we have discussed. And default means the database default isolation level. Okay, and in propagation also. We have multiple values. Requires new. If you see the documentation, they will provide some information about the propagations and all. What propagation level defines the specific behavior? Even this document doesn't define many things about the propagation, but each and every constant in the propagation will define a propagation strategy. Okay, in general, required will be used. Required means make use of the existing transaction if exists. If no transaction exists, create a new transaction. That is the propagation level. In 90% of the applications, we use required only. The propagation level as required. That means when to create a transaction means if no transaction exists. No transaction exists, create a new transaction. Otherwise, make use of the existing transaction. That's the required property. That's the required propagation level. Okay? Not supported means if no transaction exists, okay, execute non-transactionally. Okay? Likewise, each and everything will have a specific meaning. Just you can have a Google. Okay? What the propagation level required means, what requires new means, what non-supported means, what never means. Okay, some of the interviewers will be asking, what are the different propagation levels available, and what is the difference between required and required new, like that. Just Google for the propagation properties, propagation strategies. Okay, propagation in Spring, you get always 7. Okay, and for each and everything there will be a description. What required means, what required new means. Okay, just when to create a transaction. The propagation strategy will tell when to create a transaction, whether to make existing or create a new one. In some propagation strategies, what happens is, if existing is already there, even if existing is there, it will create a new one, irrespective whether existing is there or not, it will create a new one. In some, if existing is there, it will make existing, otherwise it will create new. In some propagation strategies, if only existing is there, it will make use of existing, it will not create a new one. Okay? Each and everything will have a specific meaning. Just Google for that, you can find the difference very easily. So, you need to correlate. What's the difference between required and required new? What's the difference between nested and mandatory? What's the difference between not supported and supports? Okay? Like that, you need to correlate that. Okay? This is your task for the day. Not the whole day, just Google for that. Okay? Now, once we have the knowledge of what is isolation and what is, all of you have the knowledge of what is isolation and what is propagation. Okay? Once we have the knowledge of isolation and propagation, by making use of isolation levels and propagation strategies, we maintain the transaction using Spring. Okay? Now, we have different ways to maintain transaction in Spring. Okay, the first way is programmatic approach. Second is declarative. And third one is schema based. And the fourth one is using annotations. There are 4 ways that we can maintain transaction in Spring. These are the 4 ways of maintaining a transaction in Spring: programmatic, declarative, schema based, annotations, using annotations. Now, programmatic transaction management is very less used. Just programmatic transaction management means rather than configuring the transaction related stuff in the XML files, we do it through the application, we do it through the program, which is very less used. The first approach is very less used. Okay? And the second one is declarative transaction management by using AOP. Second approach is declarative transaction management. Declarative transaction management means managing the transactions through declarations. Okay? Through declarations and dependency injections. That means by declaring some tags, by declaring some attributes or some properties, okay? By declaring some attributes or properties, we can, okay? We can, by declaring some attributes or properties in the Spring configuration files, okay? By declaring some attributes and properties in the Spring configuration files, we can maintain the transactions. Let us see how we can do. And the very use currently is schema and annotations, but we have not discussed schema. Okay, we have not discussed what is XML schema. Okay, so that it will be very difficult for you to understand. Okay, after some days, probably when we find time, we will discuss how XML is and how schema will work. Okay, then after, once again we will discuss how we can manage the transactions through schema. But it's not that much required. It's not that much required, but if we have time, we'll discuss one weekend. What is XML schema and how can we can maintain a transaction using XML schema. Okay, if they are using up to Spring 2.4, if the applications are using Spring 2.4, then definitely declarative transaction management is being used. After 2.5 only the schema and annotation scheme. If they are using the latest version of Spring, then they are using schema based or annotation based. But more than 60 to 70% of the applications are using still 2.4 itself. So they are using declarative transactions through AOP only. Some 40% of applications are using either schema based or annotations. So even if you explain that I have maintained the transactions through AOP, then it is a fine thing. Nobody will question you. Since we don't have much knowledge on schema and this annotations is pure 3.0. Okay, before 3.0 we did not have annotations in Spring. Annotations in Spring were invented in 3.0 only, the very latest version of Spring. So we did not discuss how Spring annotations can be used. Okay, it's not that much mandatory, even you can learn. Okay, but the main thing is declarative. Since we have discussed the dependency and injection and the declarative approach, okay, the declarative approach for defining the beans. Okay, what we'll do is we discuss the declarative transaction management. Okay, and then after, if you find some ample time, if you are free for some time, then what we'll do is we'll discuss what is XML schema and then schema based transaction management. But it's not, it may be used in industry, it will be used in industry in some of the applications, but the interviewer will not expect you to know everything. Okay, you can tell that I have used declarative transaction management in my application using AOP. Okay, one will take one approach, another will take another approach. You can tell that I have taken this approach. Okay, so let us see how we can maintain the transactions, okay, using AOP. Now let us see Spring Hibernate transaction management. Let's make the person AO2. Let me close all the stuff. Let me open. percent AO which is there in Spring AOP. Now let me extend this to Hibernate DO support. Okay, so just previously there was the AOP, now I am introducing even Hibernate, so that let us see how we can maintain transaction using Spring Hibernate. Hibernate DO support. What I am doing is I am maintaining two statements. Just I am inserting the record into person as well as I am inserting the record into person audit. Okay. For each and every base table there will be an audit table, so that whenever something happens in the base table, that will be recorded in the audit table. Okay. When that person is being added, when the person is being updated, who updated the person. Likewise, the audit will be maintained for every table. Okay. Now let me have a person in the model. I have a person. Okay, and let me even have a person audit. Okay. Okay. Now this is the person audit which contains audit ID, person ID, modified by and modified audit. So understood what the person audit will do? Okay. When this person ID is changed and who has changed, when it has been changed. Okay. This is the person audit. Okay. Now in the model object I have person as well as person audit. Now let me copy the configuration file from the Hibernate. Let me keep it in src hibernate.cfg.xml, and from Spring hibernate.xml let me copy the data source and all the stuff. To spring-aop.xml. Shall I remove? All of you have this example with you? Spring hyphen which was shared earlier. So shall I remove all the comments and shall I remove all the advices that we have? Where is the printer? Here? Now let me configure the Hibernate related stuff here. Just I'm copying and pasting just because already we have discussed this stuff. Now let me configure the person DO with Hibernate properties. Okay, now if I have a person service, I have a person proxy, okay, where we configure the advices, okay, this we have seen, AOP proxies, okay, and we have a data source. Do you know what is the importance of data source? Yes, just to configure the database properties, okay, the session factory. Okay, we have configured the session factory also. The session factory which has a data source and Hibernate properties. Okay. Now the session factory we have injected in the %DO, and the %DO contains is inheriting Hibernate DO support. Okay, which automatically gets the session object. Now let me just do this. Just I'm saving the person object. Now let me write another record. Insert person audit. Whenever I insert into person, at the same time I should insert into the person audit also. Okay? Now, let me try to copy the HBM files also. Let me develop even person audit HBM. Now, what is the package structure that we have here? pom.hcu.spring.aob.model. So, let me give the same package structure. Okay, and even person audit also. Let me give the same package structure. And what is the class in the person audit? Understood what we are doing? Just we are configuring the HBM files. Okay? In the person audit, we have audit ID. Okay? And what is this thing? Next one? Person ID, which is a string. Person ID is a string or int? Person ID is int, right? Person ID is int or string? Int. Let me make it int. Now I have made the person ID as int. Now, what's the property name? Person ID. Let me make it this person underscore ID. Type is it. Okay. What's the next property? Modified by. Who has modified? Who has modified the person information? Okay. It's a type of string. We need to give type. The default type is string Hibernate. Okay. Now, next is modified order. When the person record was modified. See, this kind of audit will be maintained for any base table in any application. Understood? Now, I have HBM with me, person.hbm.xml with me, and person audit.hbm.xml. Let me try to configure these two. In person audit.hbm.xml also. Now I have HBMs ready, okay, and I have the DO class ready. Okay, I'm inserting person and I'm inserting to person audit. Now let me have the service class. Let me have the add person method. In the add person method, what I am doing is, let me take the person. And let me create a person audit table. Person audit dot person ID should be the ID of the person. Okay, understood? Now, person audit dot set audit ID set modified by is Rajesh. Set modified on as it is of java.util. Now this is the person audit. Now let me dot insert into person table as well as insert into person audit table. Now if there is any problem into the person audit, in insertion of the person audit. Okay. Now should the person table should be inserted or even it should be rolled back? Let's consider like the person table query doesn't have any problem. If there is a problem in the insertion of person audit, then even the person related stuff should be rolled back. Understood? So let's consider like I am inserting a record into person table as well as a record into person audit table as a transaction. Let's consider like while inserting the record into person audit, if there is a problem, then even personal information also should be rolled back. Okay, that's the level of transaction that we are going to achieve. Now we have completed the service. Okay, now let me go for the manager. Okay, let me simply create a person object. And try to add the person. That's it. Now it comes to the service. Okay, from the Spring AOP manager, it comes to the service. In the service, what we are doing, we are creating a person object and we are inserting the person as well as a record into the person object. Okay, if we see in the DO extends to Hibernate DO support, where the Hibernate related stuff is injected here. Okay, and we are saving the person as well as we are saving the person object. Okay, now if we see in the Spring configuration files, we have a service, we have a proxy for service, we have a proxy which targets to service. Okay, and we have a data source where we are injecting the data source into the system factory and we are injecting the system factory into the DO. Okay, understood up to now? Now we shall see how we can maintain the transactions. Okay, now to maintain the transactions, okay, we should have a transaction manager first. We should have a transaction manager which manages the transaction. Okay, let me go for a simple transaction manager. For each and every database interacting stuff in Spring, it has a specific transaction manager. For Hibernate, there is a Hibernate transaction manager. For JDBC, there is a JDBC transaction manager. If you see here, we have a Hibernate transaction manager. Let me go for this Hibernate transaction manager. Let me configure the transaction manager here. Let me configure the transaction manager. Okay, the transaction manager has two things, two properties. Session factory. Now, do we have session factory object? Yes. It's a reference to existing session factory. And I think we have even data source also. Let me see. We should give even the data source also. We configure the Hibernate transaction manager with the data source properties and the session factory. Okay, that's the first thing that we need to do. Once the transaction manager is ready, then we should create a transaction interceptor. The transaction interceptor is not specific to Hibernate. It is generic for all the things, for all the ORMs and for all the transactions in Spring. Okay, the transaction interceptor is generic for all the transactions in Spring. It's not specific to Hibernate or Ibis or JDBC. Okay, it's generic for all the transactions in Spring. Now let me configure even this. This is a transaction interceptor, okay, which is generic. Now the transaction interceptor contains some properties like transaction manager and transaction attributes. Transaction managers and transaction attributes. Transaction manager, reference equal to the transaction manager. Okay, we have a transaction manager object already, okay, which points to Hybrid transaction manager. Now we have a transaction manager as well as we have transaction attributes. We have even transaction attributes. Where's the it is a transaction attributes is a properties file. Now what is the name of the method here in the service? Add person. So where is it? Name of the service is add person. Okay, then for this service, what are the propagation levels that we need to have? Just we can set the properties like this. Propagation underscore required. Okay, if you want to set multiple properties, multiple transaction properties, then separate them by comma. Isolation underscore synchronize something. Okay, the transaction attributes can be set. Multiple transaction attributes can be set by separating through commas. Now this will complete the configuration of the transaction interceptor. This transaction interceptor. This transaction interceptor will act as advisors. The transaction interceptors will act as advisors. So what we do is we configure them in the interceptor names. Okay, that's why we configure them in the interceptor names. Understood what we have done? Now is there any specific thing that we have? Data source is fine, session factory is fine, DOI is fine. Now let me make it step by step. Okay, first we have a service, person service. Right from the model, let me make it. Okay, we have a person class which has a person ID and person name, and we have a person audit which has the person ID and the audit information when the person was modified and who has modified the person. Okay, like that. What is the person ID that is being modified? Like that. Okay, and we have the corresponding HBM files, person HBM as well as person audit. Person HBM, person audit. Okay. Now, if you see the Spring AOP Manager, what we are doing, just directly we are getting the proxy bin and we are creating a person object and we are executing the add person. Okay. In the add person, what we are doing, just we are creating the audit object. Parallelly, we are inserting the record into person table as well as the record into person audit table. Okay. These two should be transaction. If there is a problem in the person audit, even person record also should not be inserted. Okay. Now that's the thing, and that's the requirement that I have. And if you come to the DAO layer, the person DAO contains two methods: insert person and insert person audit. Okay. And insert person, yes, I'm saving the person information, and insert audit, I'm saving the person audit information. Okay. And this extends to Hibernate DAO support. And if you see in the configuration file, the person DAO we are injecting the session factory. In the session factory, the same data source. In the session factory, we are injecting the data source and the HBM files. Okay. And now, once the Hibernate setup is ready, then we need to maintain the transactions in Hibernate. Now, in order to maintain the transactions in Hibernate, the very first stuff that we need to have is Hibernate Transaction Manager. We need to configure the Hibernate Transaction Manager with the bin ID. Okay, in Hibernate Transaction Manager, okay, we should inject the session factory and the data source. That's the thing. Once the Hibernate Transaction Manager is ready, then we should go for Transaction Interceptor, which actually acts as an advice, or which actually acts as an advice in the transactions. Okay. Now, the Transaction Interceptor just has a reference to the Transaction Manager and the Transaction Attributes. The Transaction Attributes is a properties value, a key value pair, to which method, what are the transaction attributes that we need to apply. Okay, and once that interceptor is ready, then we need to inject this interceptor as an advice to the proxy. Now we have a proxy and we have a target which is a person service, and we have interceptor names. We have injected the transaction interceptor as a proxy to the we have injected this transaction interceptor as an advice to the proxy. How we can inject advices to the proxy means in the interceptor names. Sure? Now let me try to create let me delete that, truncate the table. Now there is no row in person table. Okay. Now let me create audit. What are the columns in person audit? Audit ID. Okay, which is varchar 52. This is a primary key. Okay, audit ID is the primary key. And what's the next column? Person ID. Which is of type int. Okay. And what's the next column? Modified by, which is a string. And what is the next column? Modified by, which is a def. Work. Now let me comment the transaction. Now we have a table HU underscore person underscore audit. Okay. Now there are no records in HU underscore person as well as now do we have any rows? No, there are no rows in HU underscore person as well as HU underscore person underscore audit. Now let me try to execute the application. Let's try to find any problems if any. Now do we have the required jar files for Hibernate? We have the required jar files for Hibernate, but I think we don't have OJDBC.jar, which is a Oracle jar. Where are the jar files we have done? Where are the jar files? Where are the jar files?
GPIO jars in the folder.
GPIO jars jars ಇದೆ ಸ್ಪ್ರಿಂಗ್ ಅನ್ಸ್ಬೇಕು ಜಾರ್ಸ್ ಆಗಿದೆ. I think let's see if we have them in more H pendrive. Let me search here. This search ekkడుంది? ఇది direct search. Searches వస్తుంది కదా. ఈ మల్లేష్ Java Review Workshop software jars. Okay, we have this not required research. This I have a old individual jar, which is a driver class for Oracle. Oracle thin driver. Now that's the stuff. And the next thing is we need to have this kind of grammar here. And only it will be available. The grammar will change for transactions. Okay. Now, except this, the remaining thing is the same. Okay. Now let me try to execute the stuff. What it's doing is inside add person, it's going for person DO. Sorry, the message is the same that I have got. Person DO. Insert person on. Now, is there any row in the person audit? Is there any row in the person? No. Okay. Now let me try to execute again. Do I have any row in the? See, person DO insert person is executed, and person DO insert person audit also executed. But there is a problem while inserting the person audit. If there is a problem while inserting the person audit, is the person related stuff committed? Is the person related stuff committed? No. Then somebody told us. Okay? There is no commit in the person table. Just because they are under a transaction. Just it is maintaining the atomicity. One or none. Okay? If there is a problem while inserting in the person audit, then the person information is also not committed. Okay? Now, if we see here, there is a problem just because it's expecting a ID, primary key. But did we give any primary key for the audit? See, person audit for person audit.hbn.xml, what I have done is I have made it assigned. That means through the application we should give the primary key. Now, did we give the primary key through the application for audit? Did we set the audit ID? Did we set the audit ID? No. So it gave us an exception. Intentionally we have done that. Now, since there was a problem in the audit, even person record also was not inserted. Now, let me set the problem. Let me set the audit ID as 1. Let me set the audit ID as 1. So, the person audit record will be successful. Now, let me re-execute the same stuff. Now, if there is no problem, then only the record will be inserted into person, and then only the record will be inserted into person audit. Understood? Both will come under a transaction. If there is no problem in inserting the person audit, that means if multiple SQL statements are under the umbrella of a transaction, it will be one or none. Okay, it will be one or none. Okay, if at least one transaction is failed, then none of the transactions are committed. Now, since there is insertion, if you see person is inserted, as well as audit also inserted. Okay, understood how the transactions can be maintained? Okay, we can set multiple transactions attributes. Okay, based on the requirement. Okay, this is the basic idea how we can maintain a transaction using Spring AOP. Let me come once again related to the configuration. Okay, first we have a DO, we have a service. DO will be injected into the service, and service will be a target to the proxy. Okay, and we have multiple interceptors in the service. Each and every interceptor is an advice. Okay, that's separate. Now let me come to the actual Hibernate related stuff. The Hibernate, we have a data source and a session factory. The session factory, we have configured the data source as well as Hibernate properties as well as public resources, which is common Hibernate configuration, Spring Hibernate configuration. Now we are injecting the session factory into the DO, which is also a normal Spring Hibernate configuration. The new thing that we added now is the transaction manager and transaction interceptor. Okay, we configure the transaction manager with Hibernate transaction manager, which is having reference to the session factory and the data source. And we inject this transaction manager into transaction interceptor, okay, which actually acts as an advice for the transaction management. Okay, we need not to define an advice for transaction management. Spring has inbuilt advice for transaction management, which is a transaction interceptor. Okay, now just in the transaction interceptor, we inject the transaction management and the transaction attributes. What are the transaction attributes that we need to maintain for a specific service method, which is maintained as a key value pair? Okay, and then this transaction interceptor will be injected into the proxy as a address. That's how we can maintain the transaction using Spring AOP. But this can be made very much simpler if you go for schema or annotations. Okay, once we discuss the XML schemas, we'll discuss about that stuff. Understand? And this will complete the Spring. Okay, and tomorrow I have some work. Okay, so day after tomorrow we'll discuss log purchase. Okay, tomorrow there will not be any class. Day after we'll discuss log purchase. What's new? We are not connecting. We are not connecting the person table with the adult table. But what we have done in where is this? In Spring AOP.xml, what we are doing? The person service is a target for. We have configured the person service in the proxy. In the person service, what we are doing? We are configuring a transaction interceptor. Again, in the transaction interceptor, what we are doing? We are telling that for add person, this is the transaction attribute. That means for whatever the database transactions that are happening in the add person of the person service, for whatever the database transactions that are happening from add person of the person service, they should be transactions. That means we call person insert person and person audit. There is no problem in insert person, but there is a problem in insert person audit. So even the insert person also will be reverted back, will be rolled back. The transaction management, as we had discussed earlier, it will be at the service level, not at the DO level. Okay? Understood?
Any of the words in
Huh? Any of the transaction, any of the statement fails, then everything should be rolled back. All the database related statements will be rolled back. From the service, we may call multiple DOs. In the same DO, we may call multiple methods. It's irrespective. From that service, whatever the database operations that they are performing, all that will be rolled back. It's the requirement, right? We may call multiple DOs. We may call multiple DO methods within the same DO class. But everything should be rolled back if at least a problem is there in at least one thing. That's the transaction management. That's the atomicity. Okay?
No.
If you want to go for any other method, then what we can do, we can configure the regular expression, where it is Like star person means anything that is suffixed by person. Add star. That means anything that is prefixed by add. We can use the reservation. Okay? Then tomorrow we are doing that. Therefore we will discuss about it.